recording, and I'll start sharing my screen. Okay, good morning again, everyone. So I know that learning online is not the easiest thing in the world, and you already started on the ionic bonding stuff. You already completed the properties, and it was my mistake not to check the work properly. You're supposed to do the ionic bonding work. So next time, if you are asked to do a work that is not related to whatever I've taught you very recently, then do raise it out with me to let me know as soon as possible. Okay. Okay, so let's go through work. I think I've gone through work 1 with you, atomic work 1. Atomic work 2 is this one. I'm pretty sure I went through this one with you already as well. Was there anything in this work that you want me to go through again? You can just unmute yourself and tell me, is there anything at all? So this is work 2, yeah? I mean, I've just randomly opened up one of these work. This is Carrier from Land Science 2. Is there anything in this work that you want me to go through? Anything you don't understand at all? It's fine. Okay.
Yeah.
If you got questions, okay. So work 3 was this thing on calculation. Quite a lot of calculations on relative atomic mass. I realized that, for example, if I open up some of your work, I think it was people like Shaira. You see, so this is Shaira paper. So you see, like she has only written down one part of the definition. By right, the syllabus, the Cambridge syllabus. If you look carefully in the notes, I might have made a mistake of not following the syllabus word by word. It's actually the average mass of the isotopes. If you follow the syllabus, you will see the average mass of the isotopes. And this is relative to 1/12 times the mass of one atom, or n atom. N atom means one atom of carbon-12. So I think most people are okay with definition now. You know that, you have to follow the Cambridge curriculum, okay? You can change it slightly, but you got to have the term average, you got to have the isotopes, you got to have the 1/12, you got to have 1 or n, you got to have this atom of carbon-12 there. Isotopes. I think a lot of people know about the definition, but you still keep on getting tricked by MCQ again and again and again. So you need to be careful, like you know something, then do not just know it for the fact of it. You need to know how to argue with yourself, keep thinking about the definition ahead and argue with yourself. When you're about to say something, argue with yourself, meaning, go against yourself. You need to have the thing, what makes it correct, what makes it wrong, that kind of stuff, yeah? Is there anything in work 3 you want me to go through in particular? Going once? Going twice?
No.
Everyone happy with work 3? Okay. Make sure you can do the math, yeah? So we talk about averaging. We also talk about counting protons and electrons. Electronic configuration is electrons. Based on the charges is what you see, electrons. But then protons and electrons could be different when you have ions. Only when you have atoms, then the number of protons and electrons are the same. This is called working backward, yeah? I hope people already understood their mistake. And I think in work 4, what is in work 4? What do I have in work 4? Who do I have? Nope, there's Apika Pindi. This one I'm looking at, don't know, let's look at Marfua one. So this is work 4 multiple choice, quite badly done, yeah? A few people actually score quite badly for this from your class as well as from the other class. Is there anything at all you want me to go through in this work 4? Please don't just, think about MCQ as MCQ. You need to know how to get to the answer. The how and the why is very important so that you are not tricked, okay? I practiced my entire life to not be tricked by question, and I still get tricked once in a while, okay? But then you are at the beginning of O-level, and it's quite common to be tricked now, but you don't want to be tricked going forward. So, do let me know if there are certain questions.
Sir,
yeah.
Can you explain number 14?
Certainly. Okay, so I'm going to go number 14. Every MCQ has a key to it. The key to every MCQ is the key to unlocking the question. If you can find the key, your life will be easy. The key to this question is A cannot be the answer because this is decimal. We are talking about relative atomic mass based on the definition that Shaira gave just now, which was incomplete, is to do with the average mass for all the isotopes, which means each of the isotopic mass is actually a whole number. well, kind of close to the whole number actually, but it cannot be a decimal. You cannot have a decimal for isotopic mass because that is for average mass of all the isotopes, just like the relative atomic mass in the periodic table for chlorine is 35.5, but it's made up of chlorine 35 and chlorine 37. This one is definitely out of the answer, out of the option. Now for the rest of these, you press your calculator. This is actually MCQ, so you have 1 minute for these questions. So yes, I did ask you to show the working, and you could get exactly 63.5, but it does not make sense, not because of the working, because of the definitions of relative atomic mass versus the isotopic mass, which is a whole number, and it has to follow this whole number like that because you have only lost an electrons as you pass it through the mass spec. Electron doesn't have much mass. You don't lose anything in the nucleus. You don't lose the protons. You don't lose the neutrons. So your mass is pretty much still the whole number. Does that make sense, Imelda? Well, I can go through it if you want me to, but the key is it cannot be decimal. That's number one. Okay. Number two, press your calculator. Number two, press your calculator. I've asked you to do the working. It actually takes you some time to write down the working. In a real exam, when you have 1 minute, because you know what to do already, instead of writing them down, you can press your calculator. 17 times 62 plus 33 times 63 plus 50 times 65. Because you are using percentage, so you divide the whole thing by 100%. Okay, and I can roughly tell that this wouldn't be 63.5 because if this is now based on my mathematical skill, right? 62 is the lowest, 65 is the highest. I have a lot more 65. Where is my middle point? My middle point is somewhere here. My middle point is 63.5. How in the world do I get in the middle here? I have a lot more of these compared to these. So definitely my average would be somewhere closer, greater than 63.5. That doesn't make sense there. You can of course think about it, in terms of the numbers like that. Of course, the easier thing is press your calculator. Okay, any other questions in the multiple choice work 4 that you want me to go through? I've returned all your work, right? Everyone already marked it on your paper because I will not mark it again, yeah? I marked it once already. I returned it, within a few days after you submitted. I try to highlight your mistakes and stuff, so you should be able to spot your mistakes as well. Anything else in work 4?
No.
So the people who didn't say anything, you sure? Okay. Well, anything you're unclear about, you can always go back to the topical playlist. The work tutorial have been released as soon as everyone has submitted the work. So they're always there for you to refer back to, yeah? Now on to work 5. Was there anything in work 5 you want me to go through? Let me just try and use Anna's paper. So work 5 are another series of multiple choice. Again, multiple choice are not given because they're easy. They're given because they are actually quite tricky. And if you can get tricked today and you still make the same mistakes tomorrow, so there's no improvement. Okay, you got to learn how to annotate on the question and what to look for. I think Anna's paper is a bit blurry, so I probably go for my own work 4, work 5. Is there anything in work 5 you want me to go through? Just shout out the question number you want me to go through. So work 5. Anything in work 5 you want me to go through? I can shout out your name one by one. We can go through this much faster if you actually tell me if there's something you want me to go through or not. Because by right. Yes, anyone? Is there any? Okay, I'm waiting. By right, you guys should already have gone through the question paper, yeah? Because
Question 11.
Question 11. Okay. Okay, now question 11 is again about relative atomic masses. These are a series of statements. Okay. Now a lot of you chose this one. Bromine is radioactive. But okay, they might be true or they might not be true. Actually, it's not true. Okay, but you will know it. It says from this information only. This information is about relative atomic mass. How can mass tell you radioactivity? It doesn't. Okay, the masses doesn't tell you whether it's radioactive or not. Okay, radioactivity is detected by an instrument that you will learn in physics in year 11. There's topical radioactivity in physics in year 11 for you guys. All right. Anyway, so this one, you have 2 isotopes, bromine 79 and bromine 81. and they must be present in almost 50-50 because your average mass of all the isotopes relative to 1/12 the mass of an atom, carbon-12, your average comes exactly in the middle. If your average comes exactly in the middle, it must mean that you have 50 times that plus 50 times that divided by 100%, you will get roughly around 80. Okay, so that is the very reasons why this is to do with the masses, the different number of protons. Some people have foolishly chosen this option. They are isotopes. They are the same atom with the same number of protons. Okay, oxidation state, you haven't really learned it yet, but once you learn oxidation number towards the end of your year 9, you will know that these things have the same oxidation number. Okay, the only thing that makes sense is to do with the masses, and you've just learned about the masses. Hopefully that makes sense there. Any other question in this word?
No.
Okay. I think there was one question in particular that was very badly done. A lot of you chose A, yeah? Okay. So that means a lot of you did not read the question on outer shell. So quite a big issue, yeah? So by year 9, you should be able to read. Some people think they can read, okay? But when you get tricked easily by question, you need to keep your eye open, okay? So multiple choice is full of loopholes like this, and not just multiple choice, any subject, any questions, you need to know how to read the questions. And I circle and underline not because I like it, but because it has to be done, because I'm naturally a bit blind. So I need to show myself, I need to remind myself all the time, you know, these are part of the exam skill, yeah? This was very badly done. A lot of people, they know H2O. They know H2O is water. We did that as part of MR, as part of formula. We also know H2O water, right? 2 hydrogen and 1 oxygen. What people don't understand is there are 2 hydrogen, and it's about the combination of the masses. With this, we did this kind of similar question, not the exact question, similar questions in the lectures, in the lessons itself. So you need to, you know, try and think about the combination of masses from the different isotopes. So I hope that makes sense now to you, really. What are the 3 different things that will appear in your mass spec? So your mass spec will look like this. They will have 1 line, 2 lines, and 3 lines. What I cannot tell you is whether they are 1, 1, 1 intensity, but you will definitely get 3 lines. You will get 18, you will get 19, and you will get 20 there. Okay, and this is mass of a charge, and this is percentage abundance, something like that. 3 lines because 3 different mass combinations that are different. These are the same, they will overlap at 19 at the same place. Okay. Any other questions in this work 5 MCQ? Work 5 MCQ. Any other questions?
No.
Okay. So atomic structure topic is not too bad, but it's very important for bonding. Now that you have started bonding, I think you know about the formula of ions and stuff, and they come from the idea of atomic structure. Okay, so far no more questions on work 5, yeah? All good? Well, go through the syllabus, go through definitions, work through your definitions and know the calculations, especially counting protons, electrons. I think Africa last time had a big issue, you know, with plus and minus, gaining and losing. Careful, yeah? Cation ions, positive ions, metal atom lost electrons. Okay, follow the gaining and losing electrons. Is there anything in the bonding work you want me to go through? Anything you don't understand so far? I mean, your work 1, I don't want to give away the whole thing. So let me just duplicate that, and then I'm just going to quickly remove my answer so that you can't see it. Okay, is there anything in this work you want me to go through? I mean, it's supposed to be your work, but you must have gone through some of it, right? So is there anything at all you don't understand in the work that you're supposed to do? So you have to submit this today, huh? Can it be done?
Yes.
Okay,
Question
all right.
8.
Question 8?
Yeah. Question 8, yes, 8.
Question 8. Okay, this is a structured question at marks, okay? So people are so used to questions being broken down marks, you know, bit by bit. So you have to read the question and try to think about how the marks are going to be distributed, okay? So here, this is melting point. Melting point means going from solid to liquid, okay? This is what you're thinking as you read the question. Do you think 114 is high or low compared to 662? So what do you think, Marfua? Is this high or is this low?
Sorry, what?
Is this a high value or is this a low value? It's about melting point, right? Do you consider this high or do you consider this low melting point?
Low?
Okay, it's actually considered quite low, yeah, okay. Anything below 200 or 300 is considered low. Anything above 500, 600 is considered quite high. So it was my bad that I asked you to do this question before you have done the other one. Actually, you should skip this question first, but since you already started asking it, I'll start go through a couple of things, yeah? So this is a metal. This is a non-metal. Okay, this is a diatomic molecule. This is actually an ionic compound because it's formed between a metal and a non-metal. So what you have is Na plus and I minus. The two in front, this is a balanced chemical equation. The two in front means you have two of that NaI. So you have one and you have two. So altogether you have two Na plus and two I minus like that. But in one formula unit, you learn about the crisscross of the valency. You know about Na plus and I minus. The valency follows the charges. The charges is plus one, so the valency is one. The charges is minus one, the valency is one there. And then when you crisscross, then when you exchange the valency, you're gonna get 1 and 1. This is also what you know as lowest common multiple. This is when the charges have to be cancelled out. Plus one of it, minus one of it. Overall compound has no charge. That's why the formula is NaI there. You haven't learned covalent bonding yet, so you can probably skip these questions, okay? I'm not gonna require you to do this question. We're gonna come back to this question after you finish covalent and metallic bonding. This one is metallic bond, and then this one is ionic bond. So that is the bonding, okay? And you will learn about the structure eventually. But so far, what you can do is you can do the melting point of ionic compounds. Why the melting point of sodium iodide is very high? Well, because you have got giant ionic structure. So this is straight from the notes. Whenever you have ionic compounds, you will say the ionic compound has giant ionic lattice structure. We are talking about melting. So straight from your notes as well. So what are we breaking? When we melt NaI, we need or we require to break. So what are we breaking when we melt ionic compound? Can anyone tell me? I don't know. Is Anna there? What do you need to break when you melt ionic compound? Are you there, Anna?
Break the bonds.
Okay, you see, you say break the bond. You say strong attractive bond. Every bond is attractive, but not every bond is strong. So when you say the strong, that's the correct adjective. But when you talk about ionic compound, you have to break the strong ionic bonds. This ionic bond is between the cation and the anion. We read our questions. Our cation is Na plus, our anion is I minus. So this is between the Na plus and the I minus. Remember your structure is basically Na plus surrounded by I minus, then alternating cation and anions because it's a giant ionic lattice structure. So it continues, you know, up, down, front, back, left, right. So it's a three-dimensional giant lattice structure. And you have strong forces of attraction, which ionic bond is defined as electrostatic force of attraction between oppositely charged ions, between cations and anions. They are the same definition. And you will learn more about the melting point of iodines later on when we cover covalent bonding next week. Okay, so you can skip this question first. Okay, I'm going to ask the other class to skip this question as well. All right, any other question besides this question? So skip this question, you won't be able to finish it yet. Any other questions besides that question? Everything is okay? I think everything else should be in the syllabus, okay? But I just want to highlight a couple of things, yeah? Whenever you draw dot and cross, remember, think about what happened. Think about what happened to things like this. This happened in the notes as well, yeah? Lithium atom in the periodic table is 2,1. When the lithium atom forms a fully filled outer shell, metal would lose electrons. Group 1 would lose one outer shell electrons. Group 1 all have a +1 cationic charge. This one, when you lose the 1 electron, you're only left with 2 electrons in the first shell. Number one mistake with a lot of students is they always draw 8 because they always think 8. But you know about helium. you got tricked by helium so many times in the work, and therefore you shouldn't get tricked again and again, because you know the first shell, fully filled first shell, is only 2 electrons. So be careful about this kind of things. Yeah. When you draw dot and cross, I think I corrected some of you in your notes that you submitted. Be careful. Yeah. You're transferring the metal electrons to the non-metal. So you're transferring here, you're losing it to this one. So that means if you use cross here, you must transfer one of the cross to the other one. And when you have ions, you have to draw the charge outside. Without the charge, it is still atom, and therefore you will be wrong. Uh-oh, someone forgot to unmute themselves. Okay, anyway, so you have transferred 1 electrons to the outer shell of fluorine. You have 1 cross. You originally have 7 dots, so that will be minus. Okay, I don't want to give everything away, but just keep an eye out for things like, you know, when you have lithium and also O2 minus. This was straight from your notes, so you know about 1 and 2. This is called the exchange of valency. You can practice with this with any formula of ionic compound. This is what I label how many. Well, after you exchange the valency, you need 2. You need 2 of Li plus, sorry, and you need 1 of O2 minus, so that you have Li2 of. In terms of the dot and cross, you need 2, 1, and 2, 1, and then this will become 2 and 2 because there's Li plus and Li plus. Why do we need 2 lithium? Because the oxygen is 2, 6. You are going to transfer 1 electron there. You're going to transfer another electron there. It needs to gain 2, but the partner, the group 1, can only give 1. So I need 2 of the group 1 metal to give me 1 electron each. Then I will have 2 electrons altogether from the 2 of that. That's why it's 2 of that and 1 of the O2 minus. The charges cancel out. The flow of electrons makes sense. The story, one story follows the other story. So be careful about your movement of electrons. Be careful about atom versus ions. Be careful about your dot and cross. Be careful about your charges. Okay, I guess that's everything I have to say. If people have got no more questions, so make sure you finish the work. Skip the last question, yeah? I'm gonna ask the other class to skip the last question as well. Okay, but I think the rest of the question you should be able to do. So yeah. Any other questions on atomic structure that you want to ask? Nope, if not, then we'll call it a day here. Okay, so spend the rest of the time, you know, going through your work and stuff. And when you come back to school, make sure that you're ready for the topical test, yeah? I can't return your topical test yet because the other class hasn't had their test yet. So I'll release it as soon as the other class finish their topical test. Okay, please don't share the question. Okay, it's unethical. You know, you don't want them to do well because you share the question paper. Okay, so everyone should have the same opportunity. All right, cool. All right, you can leave now. It's fine. Have a good day, everyone.